Hello everyone, in this video I want to solve problems involving power in a circuit and different versions of complex circuits and how we deal with them. This problem is about power. It's a simple question actually, but it will help us understand how to tackle power problems. In a previous lecture I quickly told you about this, but I didn't totally solve it. So this question is talking about an electric kettle. We connect them to power supplies and they have an internal wire. A current passes through them and that current heats the wire. And as wire heats, it shares its heat with water inside, and we have a heated water that we can use. Heat exchange. We quickly discussed this before, and we'll solve the question now in total. So it says an electric kettle has a coiled wire inside that dissipates power when it carries a current, warming the water in the kettle. A kettle designed for use in England carries a current of 13 ampere. When connected to a power source with a 230 volts, what is the resistance in the wire? For that I use Ohm's law, right? General version, delta V over R. And I can solve for R. Switching those is always possible. Delta V over I. 230 volts divided by 13 ampere. My resistance should be from here. Alright, 230 over, it should be 17.7 ohms overall. Okay, that's it. Ohm's law. Quite a simple law actually. What power is dissipated when the kettle is running? I can use any version of it. I can go I squared R, or I can use I times delta V. It should all give me the same result. And the power I find should be about 2,990 watts. And that's it. A mixed circuit here, a simple one. We have a parallel section here. It can clearly be seen, and they are sharing this delta V, so we'll call this delta V total. We can decide how they are sharing it. What is the current supplied by the battery in the following circuit? I'll call that A maybe. It's also asking what is the current through each resistor in the circuit, and what is the potential difference across each resistor. So everything is asked in here. What is the total current? Let's find that first. I total is equal to delta V total over R equivalent. I know delta V total, I have to find R equivalent. For that I start with the part I can see. I can see this part is parallel, and I simplify my circuit to solve for the rest. From here I'm gonna have R equivalent 1 is equal to, let's name my resistors so it can guide me here. I'll call this guy R1, R2, and I'll call this guy R3. Okay, so R equivalent 1 is 1 over R1 plus 1 over R2 to the power of minus 1. I'm gonna add their equal resistors. We remember from parallel resistances part, parallel circuits part, if we have equal resistances in parallel, if I have 2, my result will be R over 2, and we will see it here. 1 over 10 plus 1 over 10 to the power minus 1, unit is ohm, I'll have 2 over 10, inverse it, 10 over 2, so R equivalent 1 will be 5 ohms. If you can't see this is fine, just put in the numbers, take the inverse in your calculator correctly, you'll get the correct answer. So this is overall equal to this part, 5 ohms. I'm going to go ahead and simplify my circuit now. I'm going to replace those two resistances with one R equivalent. That is 5 ohms. And I'm going to have this. So I have here on the right side, I replace these two 10 ohms by R equivalent 1, that is 5. Well, not 50, 5 ohms. And R3, sorry, was also 5 ohms. Now what I have is two resistors in series. And I'm done with the R equivalent. They are in series. So overall R equivalent will be just adding them, R3 plus R equivalent 1. Total R equivalent will be 5 ohms plus 5 ohms, 10 ohms. Now going to even simpler, I'll draw it smaller here because I want to have some space for some more solutions. My circuit becomes very simple circuit with one power source and one resistance, that is R equivalent. I can draw it on this side or I can draw it on the bottom there, doesn't matter. I have only one resistance. That's a resistor, that's R equivalent, that's 10 ohms. And I have my delta V total, 10 ohms, 10 volts. So it ends up being a very simple solution actually. There will be a total current drawn here, plus to minus, right? And that I total is equal to, as I described up here. Let's solve it up here. Delta V total is not 12, 10 ohms, 10 volts. And we found our equivalent to be 10 ohms, so 1 ampere. 1 ampere. So I'm going back to my original circuit. And I was asked to find current passing through each resistor. I know I total now. And that's 1 ampere. Let's see if I can solve for anything simple. Using junction rule, 1 ampere here will be divided into two, right? I1 and I2. And I know these guys have the same potential difference. Let me show them here. Delta V2 is equal to delta V1. Notice here, I was warning you about one thing. They are not always equal to epsilon here, or delta V total. And this is a case. Delta V1 is equal to delta V2. But they're not equal to delta V total or epsilon here. Because I have this guy and they're sharing it with that. But I can solve something easily. I have the same potential differences here. Current will divide into two. Same potential differences, same resistances. Current is equal to delta V over R overall. So these guys will be equal. Divided into equal parts, 1 ampere will be 0.5 ampere. 0.5 ampere. Now I know the currents passing through R1 and R2, 0.5 ampere. I got my answer for 2 already. Right, 0.5 ampere. These I1 and I2 comes here to this junction, right? And they combine, out goes I3. And I1 plus I2 should be equal to I3, right? Junction rule here. So I3 should be 1 ampere. Or I can say this guy is starting here, 1 ampere, going, divided into 2, and then recombining here, it will be the same. I3 is equal to I total. That also would give me the answer. But I can also add I2 plus I1, and that will be my I3. 1 ampere. After finding all the currents, now I found the currents. Let's list them here. I1 is equal to 0.5 ampere. I2 is equal to 0.5 ampere. I3 is equal to 1 ampere. I can go ahead and find delta V1, delta V2, delta V3. This version of Ohm's law. Delta V is equal to IR. So delta V1 is equal to I1, R1. Delta V2 is equal to I2, R2. Same I, same R. Results will be the same here. And delta V3 is equal to I3, R3. These are 0.5 times 10, so 5 volt here. The same there. And 5 volt here, 1 ampere, 5 ohms. Notice they have the same potential difference. And over here, this first simplified circuit could also tell me that. I found our equivalent for part 1, the parallel part, is 5 ohms. And R3 is 5 ohms. My total potential difference is 10 volt. Series circuits, they have the same current. I total actually is passing through all these. That could also help me find an I3. This should be I total as well, which is also I3. And this simplified, first step simplified circuit also tells me same current, same resistance, same potential differences. They will share the potential difference equally. I have 10 volt. This guy will take 5 volt. And this will take also 5 volt. I messed it up here quite a bit, but where should I draw that? Maybe with a red one will work better. 5 volt across here. You might be confused, like who takes this 5 volts? R1 or R2? And guess what? They are the same. 5 volt is equal to delta V1 equal to delta V2. Parallel arms always uses the same, always have the same potential. So if I find an overall potential for our equivalent for a parallel section that is simplified, I will have the potential differences for each because they're always equal to each other. Hope this was helpful. This one is just asking what is the equivalent resistance. Second example here. It could be confusing and stunning in the beginning, so what I want to do here is I want to start from a part, a section, a small section that I'm sure if it is in series or in parallel. Generally, there is a section of that. I'm not sure about this part here. It's so confusing. Not this part here. But look over here on this side, I have these two. If I separate this section, they're in series, I am sure. And I'm going to go short here. Our equivalent one is just adding them. 10 ohms plus 5 ohms, right? 15 ohms. I'm sure now I combine these two into one. So I simplify my circuit a little bit. Everything else stays the same. Now I have this guy here. I have that guy here. I have this guy staying the same. And I have that. Right? I only simplified the very last part to one resistance, which is 15 ohms, not 150. What did I do here? Oh, dear God. Alright, 15 ohms, not 150. Sorry about that. So 15 ohms, simplified this part here. All the rest stays the same. This was already 15 ohms. I'm writing them back. 2.5 ohms. I'm also going to delete these parts that will mess up my figure here. Alright, my computer is not enjoying the eraser again. Okay, this is 2.5. For the parts that I wasn't sure about, I'm deleting. So I'll have a less messy figure here. Alright, I'll leave it. 2.5 ohms, I have 5 ohms here. This guy is 10 ohms, and that's it. This is my simplified version. I still have a lot to do, but it's simplified a little bit. Then I'm going to look for what I can solve easily, what I'm sure about. And I am sure these two guys are in parallel. So I'm going to solve for them. R equivalent to two equal resistances in parallel will be equal to 15 ohms over 2. I'm going to do this shortcut now. 7.5 ohms. Now I simplified that guy too. I'm moving back here to have some space. My 5 ohms on the left stays the same. My 10 ohms here stays the same. My 2.5 ohms stays the same. And I simplified 15 to one resistance. And it's 7.5 ohms. And I'm going to pick it apart again that I can easily solve. Guess what? These are in series. I can easily see that. Series. So for this part are equivalent 3. I'll call it series. I'll add them. 2.5 ohms plus 7.5 ohms equals 10 ohms. Now I have one resistance on this part here. I'm going to simplify again. Well, let's do that. My 5 ohm is here. My 10 ohm is here. Quite simplified now. I have one only left on the side. Here, 10 ohm as well. 10 ohm, 10 ohm, 5 ohms. These two 10 ohms are now in parallel. I'm sure of that. I can easily see it now. Parallel. I'm going to call them R equivalent, not Q equivalent. Where did Q come from? R equivalent for 10 ohm, 10 ohm. Half of that will be my answer. When I go 1 over 10 plus 1 over 10 to the minus 1, I'll get this 5 ohms. 5 ohms. Now I have only 2 resistance. It's very simple now. I have 5 ohms here and here, only 5 ohms left. I could draw a better resistor, but anyways, 5 ohms, 5 ohms, walking alone. They are in series. And that will give me my R equivalent. 5 ohm, that's 50. 5 ohms plus 5 ohms, 10 ohms. I got my total R equivalent now. 10 ohms is the answer. And that's how we go about more complicated circuits. Then they can ask me find the overall total current, how it divides and so on. I'll go into those similar to the previous question. Okay, this will be my last question here. We'll look into this in class, and you'll have a very similar one to this one on an LC team assessment soon. So this should be good enough to go here. And this question is a little bit, makes us think a little bit further. What are the resistance and an EMF epsilon of the battery here? And the EMF epsilon of the battery here. And 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 EMF epsilon thinking about parallel arms. If I call this delta V1 across these two resistors, if I call that delta V2, they are equal. I could also call them delta V, right? Because they are parallel arms. And they are equal to epsilon, because epsilon is also parallel arm. So I can go ahead and claim this. Epsilon is equal to delta V1 equals to delta V2. And then I can go ahead and do also this. I am given the currents, and I'm going to call these I1 and I2. One is 2 ampere, and one is 3 ampere. This is I1, by the way, going down. They draw it interestingly, but this is I1 here, 2 amperes. This is I2, this guy here, what passes through that. And I know what I1 and I2 are. So what I can say is epsilon is equal to delta V1, I1 times R1, I'll call this guy R1, and delta V2, I2 times R2, or maybe I'll call it R equivalent to, because I have two resistors here on the right arm that are in series. So I messed it up pretty much already, but this arm here in series, so if I want to find R equivalent to, it will be R plus 10 ohms. Right? Now here's what I know. I know I1 3 amperes, R1 is R. I know I2, I messed up the currents. Let me go back and rename that. I call this R1 here, so I'm going to rename this to be I1. Just renaming, no worries. And delta V1. And I'm going to rename this R2 and delta V2 because I named this R equivalent to. So the names agree with each other. So my I1 is 3 ampere, R1 is R, and I2 is 2 ampere, R equivalent to is R plus 10 ohms, and these two are equal to each other. Now I have an equation here. I can work this part to solve for R, and then I can solve for epsilon. I1 R1 is equal to I2 R equivalent to. Alright, now I'm putting in the values. 3 amperes times R is equal to 2 amperes times R plus 10 ohms. Only unknown here is R. Let's drop these amperes. It's unit 3R is equal to 2R plus 20. When you multiply by this guy inside here, this is 2R times that 20. You open the parentheses this way, right? And now my R, from here I take this guy to the other side as negative. R is equal to 20 ohms. 20 ohms. So I got my R. One thing is answered. Once I got my R, I can use any arm to solve for epsilon because I know this equation holds. I can use epsilon with this to solve for it. Works. I can use it with that if I have an equation of this sort. Either one I can use. I'm going to go for the simple one. I'm going to say now. Now I know R, and I know epsilon is equal to I1 R1, right? And R1 is equal to R. So epsilon is equal to 3 amperes times R. Epsilon is equal to 3 amperes times 20 ohms, 60 volts. It's a pretty nice question. It will be on the harder end. You have to think a little bit harder to see they have equal potential differences. And I equate the potential difference. This is the solve for unknown. This is delta V1 equal delta V2. Then I go back using the fact that each of these are equal to epsilon because all parallel arms. Remember, parallel arm, parallel arm, parallel arm. So that's equal to delta V1 or that's equal to delta V2. Epsilon is also equal to delta V2. I can use either one to reach epsilon. And I'll leave it at that, and we'll look at one more question in class.